And you know what? We actually don't need to do this as a ring buffer. No, we totally do, actually. So what are we going to do in the writing thread? I guess on the writing thread we just have to block until there's a ticket. I guess. Like, when we're about to write, we just have to stop until at least one ticket remains. Is it possible for the tickets to decrement before we write? I don't think it is, because I think what we're going to do for our design, we're just going to write out 5 frames over the course of some period of time. And we're just going to process those 5 frames. And then write out another... There's a lot of thinking here. What should the writing thread do? If the ticket count increments, if we're waiting to write, so that means we've written out, say, 5 frames, and there are no more tickets, and we're waiting to write out another one. The only possible situation that happens next is that the 5th... Oh. No, that's the opposite of what I want. Oh no, I want literally the opposite of that. I want the ith thread can only write when there are I tickets remaining. The 0th thread takes first, and it should not write until all other tickets have been taken. Then it can write. And when it's written and returns its ticket, the 1st thread. So, okay, the ith thread should only take a ticket when there are cap minus I remaining, and it should only return a ticket when there are I remaining. Alright, so we... thread I takes on cap minus I, returns on I. And so the only possibility that happens when we're the writing thread, right? So the writing thread is blocked, which means there are 0 tickets remaining. The only possibility is thread 0 finishes, returns its ticket, does this need to be a ring buffer? That's not clear to me. What do you gain from having this be a ring buffer? So what I was thinking originally is you can just place new shit. As long as there's space, you just place new shit on the end, and one of the threads will pick it up. I mean, that would be better, frankly. Just any free thread picks it up. That would be better. But then we have to have a more complicated way of synchronizing which one actually writes out the video frame. Which would require ordering them anyway. So do you gain anything? What do you gain? Let's try this version first. So I can think of some ways that we might improve on this. God, half an hour we've written no code. I can think of some ways to improve on this, but I think we'll start with the naive version and we'll see how it goes. So the naive version, we don't actually need a ring buffer. We just need a cap and the number of tickets. And what we're going to do is, for now we're going to hard code it. And we're going to go pipe video. This is where it should be done. Right, so this sets up all that shit. All valids need to be memory ordered. Yeah, I mean, these don't have to be strict atomics. They don't have to be sequentially consistent. I don't know what I meant by that, other than maybe these just don't need to be sequentially consistent. Like, I don't actually think we need an atomic store here. I think we only need an atomic store here, and this just needs to be a store release. I think that's all we need. I don't think we need this. Oh, we need this because of the teardown thread. That's the only reason. Whatever. Okay. So VO width. Do we hardcode this? Kind of. VO codec width. Yeah, sounds good. Oh, actually the codec has a width? Do I really need to restore this? If the codec has it? Probably not. Width and height? Probably get rid of that. What about depth? That's the interesting one. Width height times 3. Sauce. It doesn't look like we have depth. Can we get depth from pixel format? No idea. We'll do this. To do this properly. It's actually 3, right? What do we actually do when we blend the window? Yeah, we just copy the whole thing into the video buffer. Yeah, and what do we do with the send video frame? Oh, interesting. We just scale it. That's interesting. I don't know that. What do we scale it into? That's my question. Ah, VO frame data. Okay. In which case, we should do this, I think. To do depth. Because this one seems to have the depth of 4. Okay, so we'll do that, and then we'll go buff equals start, which equals... Oh, we actually don't need start and end. I guess like malloc VO codec height times VO codec width times VO depth if vo buff equals null. We might actually just do an error. Couldn't allocate frame buffer, I guess. I don't know. Okay, and the question is, do we start the processing threads now? When do we start the thread? I don't think it's here, right? Pthread start. It's not start, it's launch. It's init. No, what is it? Pthread create. All right, and where's this under? Oh shit. Oh, and we only synchronize when doing the rendering? Right, we just loop through every video output. That's interesting. Yeah, so I think what I want to do is I want to launch those threads now. Now, unfortunately, that means I'm going to have to keep track of them. Like a chump. T, I guess. Yes, like that. Is there such a thing as a pthread set? Can I wait on a whole bunch of pthreads? Who knows? One of POSIX's great mysteries. Alright, let's go back here. So we're gonna have to make all our threads as well. So we're gonna have to go cap. For now we'll go 3 to do pick this sensibly. And we'll go 4. Do we already have an I? No. For I equals 0, I less than VO cap, I plus plus. What we're gonna do is we're gonna go pthread create. We also need to if VO TIDs equals right. Cap. At some point I'm gonna audit all my multiplications. That's probably fine. This one's dangerous. Oh, well, not really. I guess we'll just put that down there. Okay. Okay. We'll just error again. Allocate thread IDs, I guess. Sad day if we can't do that one. We'll just go null. I don't think I care about attributes. The start routine will be